All right. So hello, everyone. My name is Jacob Creech. I work on the developer relations team here at Solana Foundation. And today we're going to kind of talk about how Solana is built for consumer applications, or more specifically, how Solana enables consumer applications to reach mass adoption. So before we get into that, we're going to kind of first go into what's the mission for Solana Foundation to facilitate Solana to become this. So we at Solana Foundation are trying to help Solana to become a decentralized blockchain that it's enabled for user-friendly applications and enables this mass adoption, this scale for user-owned and operating platforms. So we're here at ETHDenver. Most of y'all probably within crypto or work on blockchain. You probably have a very similar mission. You want to create a platform for a blockchain that enables user applications to be used by not thousands, not 10,000s of people, but hundred thousands, millions of people, so that they can actually reach that scale to make a difference, to make that user-owned and operated platform. So this is what we're doing at Solana Foundation on specifically Solana. So what we usually see, though, is that a lot of other blockchains run into a scalability problem. Whenever they get any amount of users, the gas fees start going up. You can't actually be able to use this in most different countries around the world because they can't afford to use the blockchain. So Solana is trying to solve the scalability factor because, like, if you see, say if you're using a traditional tech application online, for the most part, users that are using it, whenever they click a button on their phone, they're expecting an action or a response to be seen within about a third of a second. If a half a second or more starts passing, they might click that button again, thinking maybe they did something wrong. After 3 seconds, they probably think the application is broken. So what we see here is most blockchains within the crypto ecosystem, they can't meet that need or that expectation of applications that they use every day. They can't actually have those fast blockchains. This is why you see multiple layers. They're trying to make everything a lot faster on those extra layers. Solana's trying to do this on one single layer. And at the same time, they're meeting that low cost that enables those new markets to use Solana. They're enabling that high speed transactions that people are able to build those applications for what mass adoption requires, at the same time giving the user experience that people expect and the security that you need and expect from any type of blockchain application. So if we look at, for example, this is the confirmation times for, let me actually close this. These are the confirmation times from the Circle website on USDC. So if you see here, there's a lot of them that are more than that 3-second time. This is what you would expect as a user that thinks that the application is broken. But if you look at Solana, which is third from the bottom, that is 400 milliseconds and is the lowest out of all of these ones that use USDC. And 400 milliseconds, roughly that 1/3, that expectation that people are used to whenever they're interacting with a application on just AWS, GCP, whatever. So Solana has that ability to reach that confirmation time at scale. So there's a lot of work being done behind the scenes to actually scale Solana to this level. So I'm going to talk about 3 things. I could probably spend all day talking about the different things that scale Solana. I know some people in the audience can also do the same thing. But we're going to kind of touch on 3 of them that are very easy to, very high level understand. And if you're interested in more, you can go look up the architecture on the Solana docs and understand more like what's happening behind the scenes on Solana. So first off, we have Turbine. Turbine is basically a block propagation platform or propagation protocol that allows you to have a tree of neighbors to basically get the block through shreds to different validators across the world. So you have a validator out in Japan and you have a validator out in the US. You want to make sure that they get the information at the same time as other people in the world. So that is part of what Turbine does. There's another one called parallel execution. So Solana is one of the first parallel execution environments for smart contracts. What that means is if Alice is sending money to Bob and Carl is sending money to David, because they're not using the same accounts, there's no conflict, you can actually run those transactions in parallel. Versus what you are used to in the EVM land, where everything is serial. There are some projects like Monad trying to do the same thing, but they're not live yet. Solana already does this today. They have parallel execution on those transactions today. And as part of this account model, another thing that this enables is something called local fee market. And in theory, local fee markets, what it allows people to do is it allows people to not have to fight over global block space. So let's say, for example, on Ethereum. Ethereum, if you have some hot NFT mint happening on Ethereum, and say you're a developer of an e-commerce app, with local fee markets, what would happen is, with Ethereum, with that NFT, that hot NFT mint, you would expect the fees to go up for everybody. So your users using your application that is an e-commerce app, those fees will go up along with everybody else's because of that hot NFT mint. On Solana with local fee markets, if there was that hot NFT mint, the fees would go up, or the priority fees required to make sure that you get that NFT mint would go up. But your e-commerce app would be on a different space because it has no relation to that NFT mint at all, so it wouldn't actually increase in fees. So if we look this like in practice, so this is kind of like local fee markets in practice. There's like the average fee over time for the different epochs. So with this, we can see that, hey, fees went up a little bit, but because it's not fight or demand over global block space, you can see the fees are still 0.0001 on average. That's still, what, a fraction of a cent? And this is average. I wish I had the median chart here. The median chart's even lower, because the people that are not fighting for those hot NFT mints, they're doing fine. They're transacting the same way that everybody else expects. So this is something that local fee markets enables on Solana. And then we talked about scalability, and we kind of want to talk about reliability and resilience of the network, and that is what FireDancer is trying to do. The FireDancer is a very exciting project within the Solana ecosystem. What it does is it's adding another validator client to Solana. So today we have what is the Solana Labs client. It's kind of called Agave, which is now for Onza. They use this today, and that's the one client that runs on the network. If we add a second client, like Ethereum has, I think, like 6 clients, if you add a second client, if there's a bug in one client, it's very unlikely for that same bug to exist in another client. So what FireDancer enables is that you have that resiliency and the reliability that you would expect from any old application on the network of Solana. And there's kind of a lot more things that are going under the hood of Solana, or FireDancer, that make it very exciting. So real quick, the different clients that are kind of being built right now is like Agave, which is built in Rust, FireDancer in C, SIG in Zig. So FireDancer, what they're trying to do is, because they're building now versus building while the train was being built and running, they get the opportunity to try to optimize as much as possible that they can do on an L1. So what they're doing is they're optimizing to where like they get high throughput on their NICs. They nearly meet like the 25 gigabit NIC. They get like 23 gigs. They're still optimizing. They're able to get those high level throughputs to where the software is not the bottleneck, but the hardware. And if we're able to do that overall on all the clients on Solana, you'll get the performance that is beyond any other blockchain out there. And it's kind of like where if we optimize the L1 as much as possible, if there's ever a need for like a layer on top of Solana or something like everybody does with L2s on Ethereum, that L2 will go 10,000 times faster. So we're fully focused on optimizing the Solana clients, or the bottom L1 layer, so that people can have an integrated environment and the best user experience possible, both for users and developers. And so there's some future improvements. I have one listed here. Of course, I will mention it's not like fully accepted yet. There is a similar process to EIP that I'll mention in just a moment. So this is something called concurrent block producers. It's so that like, hey, you have a block producer, instead of just having one, you can have more than one producing the block. And also you can have a block packers that are like separately so that you can even make things even faster. But if you want to keep up with this and many of the other things that are happening on Solana today, you can kind of check out what is called the Solana improvement documents. We call them SIMDs for short. This is EIP, what you were expecting in Ethereum. This is where you can find a lot of the different discussions about the future improvements on Solana and where they are right now, as well as the accepted proposals and where they are to be built in the future and deployed in the future on the cluster. So this is happy to have y'all get involved and understand of what is going on Solana. All right, so we talked a lot about the different ways that Solana is scaling, but who's using this? As here, what we have is basically a slice of the total ecosystem applications. This is only a slice. There's a ton more. I can't fit everything on this screen. And what we see is because there's so much focus on scaling the layer 1 as much as possible so that the applications can make the best user experience for their users as humanly possible, as much as the hardware can actually allow it. We see people are building on Solana, building their applications because they understand Solana is the place that you can build for scale. I don't have to worry about, oh, I'll max out at 1,000 users or 10,000 users. You can build for millions of users, and this is what people are trying to do today. They're building those applications that match the experience that you expect on traditional tech on Solana. So we're going to kind of go into like what some people like to think of as only possible in Solana because of that consumer application, that level of scale for consumer applications. And so we're going to first talk about a few of them. I might not be able to get through all of them, but we'll start. So Helium is kind of like say you have your cell phone. It's connected to cellular service. Right now, for the most part, y'all are probably like, I don't know, AT&T, Verizon, T-Mobile, whatever. Centralized service. You're connecting to their tower, you're getting their service, and it's coming to your phone. What's cool about Helium is that actually everybody's running these basically like low-RAN antennas, and they're providing service to people that are in that smaller area. But it's because there's multiple of them, they can have a better coverage, and what's more on the blockchain side of it, as you're using these antennas of people, as you're like traveling through Denver or whatever, you're paying for use of their specific antenna. And so it's more decentralized than the current centralized cell phone providers. And it brings blockchain at scale. It's required, really, Solana is required for Helium to work economically. There's something called HiveMapper, which is a really cool project. So if you're used to like Google Street View or Google Street View or Apple Maps, you'll notice that a lot of the maps are very out of date. They're like year plus out of date. Yeah, it's because like you have a centralized entity that's trying to figure out like how can I actually go and map those all? You see those cars every once in a while. It's getting the new street views. With HiveMapper, it's basically just anybody that has a dash cam can contribute to the mapping of the roads. So it's like a really cool application that's built on Solana and economically can only be built on Solana today. So we'll move on to Star Atlas. Star Atlas is a game on Solana, and they realize because they're building on Solana, they can make, instead of like games on other blockchains, they make most of their actions off-chain, and then they bring out maybe just the NFTs on-chain. They actually can make a lot of their actions on-chain with Star Atlas. They're still being built today, but there's actually already people playing the game and using it, and they don't just have to rely on only using NFTs. They can do more things or more actions within the game on-chain because Solana is providing the user experience at scale for them. I'm going to move over to Drip just in the interest of time. So Drip is kind of like a time-based collectibles platform. There's a lot, it's probably the simplest way of saying it, but there's a lot more under the hood. They basically are minting NFTs for people off of art. Artists are minting NFTs for people on a certain time window, and it's making it collectible because it's only that time that they can actually receive them. This is enabling a lot of people or a lot of creators to be able to make a living based off of Drip. And what's really cool and what makes it only possible on Solana is today, I believe today, they have minted up to like 60 million NFTs. Might be more, but it's about 60 million NFTs. And they do this because of something called state compression. So state compression is what enables people to mint NFTs, like a ton of them, on chain, and be able to actually use them and still have the cost that would be negligible on some large company's balance sheet. So you can see like 1 million is what, 5.35 SOL today. That is like they can mint 1 million NFTs and they can keep going. The Drip team has minted 6 million NFTs and they estimate their total cost is around 16 grand. That's not possible on any other blockchain today. And this, because you can unlock a lot more for a lot less, and also it allows you to think of NFTs a little bit differently. Instead of just having those 10K NFT collections and limit the size of your audience to only 10,000 users, you can suddenly do a lot more. For example, if you have a loyalty solution and you want to mint NFTs that are like coupons to allow them to interact with Solana Pay, which is financial infrastructure on Solana, to pay for goods at your store, you can do that. And you can do that for 10 million customers for almost nothing. You'll make more on your coupons coming through and being used on Solana. So it's like, this is basically enabling a lot more to be done with NFTs on Solana, and it's today only possible on Solana. Another thing is, if you're, just to touch on tokens and the developer experience on Solana, if you're used to Ethereum, right, or any other EVM solution, you know ERC20. You probably know it by heart. It's an interface that you can basically copy and paste into a smart contract, you redeploy it, and then you have a token on whatever EVM solution you're using. What Solana does is it's slightly different. It optimizes for reusability and composability of a single program. So on Solana, you have already a program called the token program, and you can use this token program to create tokens within minutes. Like you just have to, the minutes are mostly just installing the CLI. So that command right there, the SPL token create token, will create a token with a single transaction, and it's just a CLI command. Alternatively, you don't have to write that CLI command. You can write it in any language you want that can create transactions. You can do JavaScript, Python, whatever. It'll create the tokens, and it's as easy as that. You don't have to learn Solidity. You don't have to learn Rust if you're afraid of it. You just write the small amount of code, and it immediately creates those tokens. And what's cool is tokens on Solana that you can have customizable extensions on tokens as well that create these custom transfer logic. Like for example, transfer fees. You can make automatic transfer fees on all your token transfers. This is enabled by default on token program or token extension program. You can have this with token non-transferable tokens, just a simple transaction. You can make privacy preserving transactions where you keep it private, the amount that's being transferred by default with a single transaction while you create your token. It's very simple to just add those just as like Legos onto your token without having to think, how can I build this custom logic, or worry about, okay, now I got to go build a smart contract and deploy it on chain. It's actually already built there for you. So that is a very brief overview of the scaling efforts on Solana and how Solana enables consumer applications to be built on top of it. You can find out more on like docs or solana.com/docs. If you're a developer, I would go to solana.com/developers, and we're happy to have you. I look forward to meeting the rest of you at our Solana booth this week. But thank you.